So this lesson is going to be over slope and more particularly identifying slope from tables and graphs, such as right here, a table and a graph here. So slope has to do with, it's a measure of how steep a line is on a graph. So if I give you an example right here, sometimes we'll have a very narrow slope, meaning that it's very steep, or sometimes we'll have a not so steep slope, and it'll be a more wider slope. So it's a measure of that actual line. So slope is also called the rate of change. So go ahead and write that in, rate of change. So if you're ever asked, what is the rate of change? That means, what is the slope, essentially, is what they're asking for. And the variable that represents slope is m. And that is associated with y equals mx plus b. But you guys don't need to know that for this lesson, but you will encounter this equation later on. Right now, you just need to know that m is represented as slope. All right, so let's take a look at slope from a table. So sometimes you are going to be presented with a table of numbers, x and y coordinates, and there is a formula for that, for finding slope, and it's called delta y over delta x. So this delta right here, that's Greek for change in. So that means change in. So it's change in y divided by change in x. Or it can also be y2 minus y1 divided by x2 minus x1. And the x and the 2 is representing the the second set of ordered pairs and another set of ordered pairs. So, and let's go ahead and switch to the graph real quick. We can look at the equation for that. Slope from the graph is found by rise over run. And that rise has to do with moving up or down from getting from one coordinate point to the other coordinate point on the line. So looking at this example here, you count how many units you're moving up. So first you want to identify how many units this is. So it's going 1, 2, 3. So it's in multiples of 1. So you're going to count up 1, 2. So that's 2 units. So that's your rise. You rose 2. So I'm going to fill that in for 2. And then your run is heading over to the right, and you're moving over from that point to this point 1 time. So your slope, rise over run, is equal to 2. So that's your slope for that graph. Let's take a look at the table over here. So you want to find the change going from here to here, from here to here, from here to here. So the change is, count how many units you're moving up. So 3 to 5 is plus 2. You're adding 2. 5 to 7, you're also adding 2. 7 to 9, adding 2 as well. So 1 to 2, you are adding 1. 2 to 3, adding 1. 3 to 4, adding 1. So the change in y is positive 2. So we can fill that in for delta y over delta x is equal to positive 2 over 1, which is also equal to a slope of 2. So the slope in this case would be 2. If you wanted to actually type it in, or not type it in, if you wanted to actually use the formula, so we can identify this. These are the same as coordinate points. So this 1, 3, 2, 5, that's coordinate points. So we could also fill that in for y2. So I usually like to write the coordinate points. So we can say 1, 3, and 2, 5. Identify your x1, your x coordinate. So that's the first x. This is the second x. This is the first y. That's the second y. And then you fill it in for the formula. So y2, 5 minus 3 divided by 2 minus your x1, 1. So 5 minus 3 is 2. 2 minus 1 is 1, and you get the same answer, 2 over 1, which is equal to a slope of 2. So that's measuring how steep the line is. Let's take a look at this other chart. So we have 0 to 10, 10 to 20, 20 to 30. So we know that's adding 10. It's also adding 10 and adding 10. Oops, plus 10. And you also want to identify your X and Y. So, and it gives you the graph as well. So inches is going to be your Y. So remember, that's your Y axis, and this is your X axis. So years are going to be the X, and inches are going to be the Y. All right, getting from 10 to 14, that's a positive 4 change. Also a positive 4 change, and also a positive 4 change. So your delta Y over delta X is equal to 4 over 10, which reduces to 2/5. So your slope would be 2/5. And you can calculate that over here as well on the graph. So moving from this unit to up here to get to here, we count our rise, which is 10 to 14, which is positive 4. And then from this point to this point, that is 10 units, so plus 10, which would yield you the same answer. So rise, which is 4, you rose 4, and then ran quotation marks, ran 10. Same answer, 410 is equal to 2/5. So pause the video and then try these examples on your own. See if you can find the slope of the graphs and of the tables. And I'll go ahead and work them out. So we get 0 to -3, which is -3. 3 to -6, -3, -3. Okay, we have that trend. -2 to 2 is you're adding 4, because to get to -2 to 2, you're adding 4. 2 to 6, adding 4. 6 to 10, adding 4. So our delta Y over delta X would be 4 over -3, which is -4/3. So your slope, M, would equal 4/3. -4/3, excuse me. All right, let's take a look at this graph. We could do it from right. Let's see, it's kind of hard to see in the graph, but we can do from this point to maybe this point. So similar to using Pythagorean theorem, we want to count how many units it is from here to here, which is 2. You can't really see that, 2. So rise. So starting from here, so this time the line is going down, so the rise is actually going down. So, but heading down, you're going 1, 2, 3 units. So that's -3. And then over to the right, 2 units. So your rise over 1 would be -3 over 2. So M equals -3, 2. So you'll notice that whenever you have a negative slope, the line is going down. And to help you remember that, we'll get into Mr. Slope Dude a little bit later, help you remember positive and negatives on a slope. Let's look at number 3. 0 to 8 is +8, +8, and +8. This is +10, +10, +10. So delta Y over delta X, we get 10 over 8. That reduces to 5/4. So we get a slope of 5/4. Take a look at this graph. We're moving up, so it's going to be positive. So we're going from 50 to 70. So from here to here, that's going to be +20, moving up 20. And then looking right here, we're running 25. So your rise is 20 and your run is 25, 20 over 25. That reduces to 4/5. So your slope is 4/5. All right, so we have here to here, getting to 3 to 3, that's 0. 3 to 3, 0, 3 to 3, 0. So we have 3's on all the y coordinates. Moving from 5 to 10, we get plus 5. That's adding 5, and that's also adding 5. So delta y over delta x is going to be 0 over 5. So 0 over 5. Okay, so we have a 0, so that comes out to 0. So whenever you have 0, your slope is just 0. And that means your line is a horizontal. So you have a horizontal line when you have a slope of 0. We'll get into more of that in just a second. Let's take a look at this. Let's look at this one first. So 8, 8, that's 0, 0, 0. That's the x. Can't really see it. But yeah, x, y. Moving from -2 to -4, that's -2. -4 to -6. 6 is also -2. It's also -2. So delta y over delta x is also going to be -2 over 0. But when you type in -2 over 0, you should get an error. And that's what we call undefined. So undefined is actually the answer, not the -2 over 0. So undefined. So whenever you have a 0 in the denominator, your answer is undefined. And what that looks like is this line right here. So a very vertical straight line is undefined. So this one right here would be, the slope would be undefined. And this slope right here would be 0. So undefined and 0. And to help you remember that, so heading back to Slope Dude, this one's probably a little bit easier to look at. So whenever the slope is moving up, Mr. Slope Dude is moving puff, puff, positive. He's moving up. So puff, puff, he's moving kind of slow because it's harder to move up a hill. Then once he's up in the top, he moves down, which is the fun part. It's nice, negative. So that little mnemonic, nice, negative, puff, puff, positive, nice, negative. And when he's moving in a straight line, it's 0 fun, meaning that the slope is 0. And then when he finally gets to a cliff and he falls down, he screams, which in math is the equivalent to the F-bomb, undefined. So he yells, undefined. So that is straight line. Remember falling off the cliff? Undefined. So he yells, undefined. And I think that concludes the notes.